All right, so we're going to look at the process of elimination. Now, this is going to be solving a system of equations using the process of elimination. So if we have a system of equations, um, let's say like this, we have a 9x plus a 4y is equal to negative 14. And then we have negative 5x minus 4y is equal to 6. Okay, so here we are going to actually do something fairly simple. We're going to take these two equations and we are going to add them together. When we add these two equations, okay, we're going to add it just like anything else. We can combine like terms. So when we take this equation and we take this equation, I'm actually going to look at my x's here and I'm going to combine those. Then I'm going to look at my y's and I'm going to combine those. And then I'm going to look at my constants and combine those. So if I do that, 9x plus negative 5x, that's going to leave me with a positive 4x. Okay, positive 4y plus a negative 4y, that's just going to give me 0. So I'm not even going to write that. That eliminates the y. Thus the name of the method known as elimination. Now, negative 14 plus 6, that's going to give me a negative, let's see here, 8. Okay. All right, now I've got 4x is equal to negative 8. I can very easily divide both sides by 4 to isolate that x. 4 divided by 4 is 1. 1 times x. I'm simply left with x. Negative 8 divided by 4 is negative 2. So what I've done here, in just a couple of easy steps, is I've actually already, using the process of elimination, I've eliminated the y's, and I have solved for one of my variables, negative 2. And so now that I know what x is, I can take that information and I can come back to one of my original equations here and I can plug in negative 2. Now that I know what the variable is. It doesn't matter which one we plug it into. I'm going to plug it into the second one. So we have negative 5 times negative 2 minus 4y is equal to 6. Now I just need to solve for y. So negative 5 times negative 2 is positive 10 minus 4y is equal to 6. All right, then we're going to subtract 10 from both sides. 10 minus 10 is 0. We're left with negative 4y. 6 minus 10 is negative 4. All right, then what I can do is I can divide both sides by negative 4. Negative 4 divided by negative 4 is positive 1 times y is just y. Negative 4 divided by negative 4 is positive 1. All right, so now what I have is I have the point x is negative 2, y is 1. So if I were to actually take these equations, transform them into slope-intercept form, and then graph them, what we would find is this point right here, whatever the, and I don't know what the lines look like, but I do know that the point of intersection has to be negative 2, 1. Oops, negative 2, 1 would be up here. So when I graph them, here, we'll just do a different color. Here's negative 2, and here's positive 1. So this would be whatever. I'm not sure that's even what the lines would look like, but I do know that at that point, both the x and the y work for both of those equations. And so let's see if that's true. Okay, so we've got negative 2, 1. We're going to look at this method of elimination. Let's see if this actually yields the correct answer. So negative 2, 1, we have 9. Here's the first equation, 9x plus 4y is equal to negative 14. Okay, so we're going to do 9 times negative 2 plus 4 times 1. Does that equal negative 14? 9 times negative 2 is negative 18. 4 times 1 is 4. Negative 18 plus 4 is negative 14. So that one checks out. Now let's try the other one. So using negative 2 and 1, we have the equation negative 5x minus 4y is equal to 6. So here, I'm going to plug in negative 2 and 1. Negative 5 times negative 2 minus 4 times 1. Does that equal 6? Negative 5 times negative 2 is 10 minus, or even if I don't look at minus yet, negative 4 times 1 is negative 4. 10 minus 4 is 6. And that checks out too. So this elimination method does seem to work. Now, there's different ways that we can use the eliminations. Okay, in this case, we added. You can also subtract to, let me show you an example where we can subtract two equations in a system of equations. So if you have the same variable and coefficient in both equations, and let me give you an example of where that would exist. Okay, so here you see that we've got a 7x and a 7x. You know, if we were to add these two equations, well, this would give me a 14x. This would give me a negative 14y. And this would give me a negative, let's see, 42, I think. Yeah. So obviously, if we just add them together, we don't eliminate anything. However, if we subtract, we switch colors here. If we subtract these two, okay, now remember, this subtraction is going to have to go into each one of these, okay? So let's keep that in mind. 7x minus 7x gives me 0. Okay, so those would cancel. Negative 9y minus negative 5y. Well, that would be a positive. Negative 9 minus a negative would be negative 9 plus 5. So that would be a negative 4y. Same thing here. Negative 19 minus a negative. That's going to give me a plus. So negative 19 plus 23 will give me a 4. All right. Then here, we simply divide both sides by negative 4. Negative 4 divided by negative 4 is positive 1. 1 times y is y. 4 divided by negative 4 is negative 1. So y we have calculated to be negative 1. Now, since I know the value of the variable, I can plug it into either one of these two equations. Okay, so let's go with the first one. 7 times x minus 9 times negative 1 is equal to negative 19. All right, 7x. Negative 9 times negative 1 is positive 9. Subtract 9 from both sides. Positive 9 and negative 9 are 0. We're left with 7x. Negative 19 minus 9 gives me a negative 28. So now I have 7x is equal to negative 28. Divide both sides of the equation by 7. That will get x by itself. 7 over 7 is 1. 1 times x is x. And then negative 28 divided by 7 is negative 4. So, by combining these through subtraction, we eliminated the x variable. We solved for y. We took that information, we plugged it back into one of our two equations. I chose the top one. And by plugging that in, the only variable left in the equation is x. So we were able to solve for x, and x is negative 4. So the point at which these two lines would cross would be negative 4, negative 1. That is the ordered pair, or the point on the Cartesian coordinate plane where they would intersect. All right. So I think you probably kind of have a little bit of the idea of how elimination works. We simply add or subtract the two equations together in an effort to get rid of one of the two variables. But let me throw one at you where you can't simply add or subtract, but you still can use elimination. So let's do negative x, and again, this is a system of equations. Negative x minus 4y is equal to positive 19. And then 8x minus 12y is equal to negative 20. All right. Okay, so in this case, if I were to come here and just add these two together, this would give me a 7x, and this here would give me a negative 16y, and this would give me a negative 1. So I'm not eliminating the x's or the y's. So what can I do in order to get one to eliminate? Well, the only way they're going to eliminate is if I'm going to use plus, okay, then I have to have opposite um, values of my coefficients in the two equations. So if I'm going to add, and I have an 8x here, I would need a negative 8x here. Or I would need this to be a positive 1. Here, if I was going to cancel it with this would need to be a positive 12. Or here, this would need to be a positive 4. Okay. So how could I do this? So there's one of two ways that I could do this most easily. Okay. There's several different ways to do it, but if we look here, if I multiply this top equation simply by the number 8, that would give me a negative 8x minus 4 times 8, so that would be a 32 here, y, equal to 19 times 8, whatever that ends up being. Then I would have something opposite here. That would work. But what I'm going to do is I want this. I know that if I multiply this 4 by 3, I get 12. And so that's what I want to do. If I simply multiply it by 3, I'll get negative 12. So I could come over here and put a minus sign and do negative 12 minus negative 12. But I want to keep this easy. So I want to use addition, and I'm going to make this a positive 12. Okay, so how do I do that? Well, if I know that if I multiply this negative 4 by a negative 3, that's how I would get positive 12. So what I'm going to do is I'm going to multiply both sides of this equation, okay, by negative 3. And so here, negative 3 times negative x. Okay, that's going to give me a positive 3x. Okay, and then negative 3 times negative 4. That's going to give me a positive 12y. Okay, then here, negative 3 times 19, that's going to give me a negative 57. Okay, now I have simply and I'll just rewrite this equation here. What I've done is I've multiplied both sides of the first equation by negative 3. So effectively, I've changed nothing. Remember, it goes back to a is equal to a, and if I multiply a times 3 and I multiply a times 3, 3a is still equal to 3a, right? Nothing's changed. It's still the same identity. But what it is now is it's now expressed in such a way that I have a positive 12 and a negative 12 that can add together to give me 0. Now I can eliminate. Okay. So here we have 3x plus 8x. That's going to give me 11x. Positive 12y plus negative 12y gives me 0. That's eliminated. And then here, negative 57 plus negative 20 gives me negative 77. All right, then I'm going to divide both sides of this equation by 11. The 11's simplify to the number 1. 1 times x is x. And negative 77 divided by 11 is negative 7. All right. So now that I have one of my variables, what I'm going to do is I'm going to put that into one of my two original equations. I could use this one if I wanted to. That's fine too. That's not going to give you the wrong answer. But I can use either this one or this one. I typically like to shoot for the number with the smallest numbers or the equation with the smallest numbers. Usually that means that the math will be a little bit easier. And so I'm going to go with this first one here. So we have negative x is negative 7. So we have negative 7. That's going to end up being just positive 7. Minus 4 times y is equal to 19. All right, so all I've done is taken that original first equation and I've plugged in the negative 7. So the opposite of 7, simply 7. Subtract both sides by 7. Okay. 7 and negative 7 cancel to give you 0. 0 minus 4y is just minus 4y. 19 minus 7 becomes 12. And 4y is equal to 12, or negative 4y is equal to 12. If I divide both sides by negative 4, negative 4 over negative 4 becomes a positive 1. 1 times y becomes y. 12 divided by negative 4 is negative 3. Negative 7, negative 3. That's the point at which those two are going to cross. So the only thing that was different here in this particular example of elimination method is we started with two equations that are a system of equations. We know that from the curly brackets. But if we just straight up added them together, it did not eliminate the x or the y. We had to multiply a certain number on both sides of one of the equations in order to get a scenario where you do have two numbers that are going to add together to eliminate one of the two variables. Okay. All right. Let me do one more, kind of along the same lines as the one we just did. show you kind of another um, same method, same idea, but maybe another level of complexity. Okay, so here, once again, if I were to take these two equations and simply add them together, the 9x and the negative 7x would not cancel. If I added them together, I'd be left with 2x. Here, if I added them together, I'd have 11y. Obviously, neither the x nor the y are canceling. So from just like what we did last time, is there a number I can multiply on both sides of the equation, either in my first equation or in my second, to get opposite? In other words, can I get here a negative 7? Or here a negative 4. I'm sorry, here a positive 7, or here a negative 4. Or here, can I get a negative 9? Or here, can I get a negative 7? So just by looking at it, there isn't a clean number that I can just multiply across one of these equations in order to get that. But another thing that we can do is we can actually multiply a number on the first equation and a different number in the second equation. As long as we're multiplying both sides of the equation, we're not really changing anything. But what we can do is we can then express it in such a way that we do have some opposites here that can cancel. So what if we multiply this first equation on both sides by the number negative 4? Okay. Why negative 4? Because then down here, what I want to do is I want to multiply both sides of the equation by a positive 7. Okay, now what am I doing here? Notice that when I multiply this number here by a positive 7, this number, this is going to be 4 times positive 7. This here is going to be 7 times negative 4. Those are then going to become opposite. Okay, I'll show you. So here, negative 4 times 9 is negative 36x. Negative 4 times positive 7 is negative 28y, is equal to negative 4 times 12. That's going to be negative 48. All right, then here, positive 7 times negative 7 is negative 49x. Positive 7 times positive 4 is positive 28y. Okay. And then here, 7 times 19, I'm going to have to write this one out to the side. 133 equals positive 133. Okay. So now, when I come in here and I add these two together, notice that right here, I am able to eliminate my y. Negative 28 plus 28 would give me just a 0. All right, so negative 36 plus negative 49. It's going to be a 5 here, 85. It's going to be a negative 85x. Nothing there, equal to negative 48 plus 133. So I'll just kind of do this old school. 85. 85. All right. Let me just double check that. 85, I add 3 or add 8. Yeah. Okay. Okay. So then here, negative 85x is equal to 85. I divide both sides by negative 85. Negative 85 over negative 85. That would reduce to a positive 1. Positive 1 times x is just x. And 85 divided by negative 85, negative 1. All right, now I can plug that negative 1 into either one of my original two. I'm going to use the top one. So I have 9 times negative 1 plus 7y is equal to 12. Now I'm going to solve for y. 9 times negative 1 is negative 9 plus 7y is equal to 12. I'm going to add 9 to both sides. Those cancel to 0, negative 9 and positive 9. So I'm left with 7y. And if I add 9 to 12, I'm going to get 21. All right, divide both sides by 7. 7 over 7 is a 1. 1 times y is a y. 21 divided by 7 is a positive 3. Okay, so then what we have here is our final answer, the answer to the system of equations. The point at which these two lines intersect is going to be negative 1, 3. That is the ordered pair. A little hard to get everything on one shot there. All right, that is solving the system equations by elimination.